Alright guys, welcome to 1.4. We're solving equations today. Our essential question: how do you solve equations and problems by writing equations? So a warm-up problem for you. We know the total weight is 40 ounces, and we know that each inch of the crossbar weighs an ounce. Okay, so like this part of the crossbar weighs 4 ounces. This one weighs 1 ounce anyway. And we need to find the weight of each shape. Okay, so you can do this any number of ways. How I would do it is just take it piece by piece, and I would first start working with this half of the scale. I know that this has to be half of the total weight, right? It has to be balanced, so this has to be 20 ounces. And so I can write an equation that says that the 4-ounce bar plus the heart has to equal 20. And then that's pretty easy math. When we subtract 4, the h equals 16 ounces. So we solve the heart. It weighs 16 ounces. All right, and then the same thing on this side. This side also has to weigh 20 ounces. Now this one's a little bit trickier because it actually splits again. All right, so this is supposed to weigh 20 ounces, but then we have the 4-inch crossbar here. And so really this part of the scale would be 16, right? And that's the same as what's on this side below that level. Now we can split this into 8 and 8, right? Because it all has to stay balanced. So 8 and 8. Okay, so we know that the 2-inch crossbar plus the semicircle will get us 8. And so we know that the semicircle has to be 6 ounces. Okay, so we got this one, 6, 16. Okay. Now on this side, if we want to split it again, we know the total has to be 8, and then you have the 2-inch crossbar, and so this part has to be 6. Right? And so I know that the 1-inch crossbar plus the other 1-inch crossbar plus we have 2 triangles in that grouping, that all has to equal 6. Okay, and so now I can just solve, right? I subtract, I have 2 plus 2t, oops, equals 6. Okay, and then I subtract 2 from both sides, so I get 2t equals 4, and so then obviously each triangle that I have is 2 ounces. So just something to get your brain going as far as making the scale be equal, and that's really what we're talking about today. An equation is a statement that 2 expressions are equal, and we talked about this a little bit yesterday in our warm-up, right? An equation is a statement that 2 expressions are equal. It's like a scale, you have to keep things balanced. Alright, so properties of equality. We have the addition property, which says if a equals b, then a plus c equals b plus c. Basically, you can add the same number to both sides and it doesn't change anything, as long as you add the same amount to both sides. Similarly with subtraction, you can subtract the same number from both sides and it works out. With multiplication, you can multiply the same number to both sides. That's okay. And with division, you can divide by the same number on both sides. However, you cannot divide by 0 ever. Okay. All right. So the solution of an equation: all values of the variable to make the equation true. Okay, so sometimes there may be more than one solution, especially in advanced algebra. There's going to be probably more than one solution a lot of times. So just make sure you get them all. So that's one vocab word. Inverse operations. They're operations that undo each other. Okay, so for example, the inverse operation of addition is subtraction. The inverse of squaring is square rooting, etc. Addition and subtraction. Other inverse operations, I kind of gave you one already. The inverse of squared is square root. They undo each other. Okay. Also, you know, an easy one is multiply and divide, right? All right, so solve the value of these variables. This should be pretty easy. Review from yesterday at least. Here we're going to subtract 4, right? Subtract 4. Now be careful because x does not equal negative 8. It actually equals negative 16. Okay, over here we have, let's subtract our 13. So we get negative x. Don't drop your negative sign, right? Negative x equals, what, 12? Okay, and then we divide by negative 1 to get rid of our negative sign. So we're left with x. Do it to both sides, and we get negative 12. Okay, down here we need to take care of our parentheses first, I see. So we got negative 27 plus 6y equals 3y minus 9. Now, you could divide the 3 right away if you see that, you know, 27 and 6 are both divisible by 3, but you'll never go wrong by distributing, so that's what I'm going to do. So I'm going to subtract my 3y over, we're going to get negative 27 plus 3y equals negative 9. Okay, and we're going to add 27. Left with 3y equals, what, 18? 18 divided by 3 is 6. Okay, so now we're going to solve. We got lots to do in this problem. Parentheses come first, right? We do order of operations. So we're going to distribute. So we got 6x minus 3. Then we're going to distribute again. So remember to bring your negative sign along. Negative 6x minus 8. And that all equals 11x. Okay, now we can combine like terms, right? Now, luckily, our positive 6x minus 6x, they cancel each other out. Negative 3 minus 8 would be negative 11. We divide by 11. X equals negative 1. All right. So sometimes, you know, when you're solving equations, things happen, and you want to know, does the equation like always work for any number, or maybe just like, can you pick any number, or maybe it never works, stuff like that. So you know that it always works when you end up with something like super obvious, like 3 equals 3 as your final answer, or maybe your final answer is like 7 equals 7. Okay, that means that you can plug in literally any number to that equation and it's going to work out. Okay, usually we define that as like all the real numbers. Okay, and that's kind of the symbol for the reals. So you can literally plug in any number you want and the equation is going to work out. Now, if you end up with something ridiculous like, let's say negative 1 equals 10, well, that's never true, right? And so you're never going to, no number you come up with is going to make that equation work. Okay, now, sometimes the number you pick will work when you end up with something you expected, so such as like x equals negative 1, right? Sometimes the number works. Like if you just threw out the number 7, no, that wouldn't work in this case. But if you picked negative 1, then yes, it does work, right? And so sometimes the number will work if you get something that you expected. Usually it involves a variable like that. All right, so here, first off, we need to combine like terms. So we get 3x plus 6 equals 3x plus 4. Okay, now when we subtract our 3x's, lo and behold, they disappear. Poof, abracadabra. And we're left with 6 equals 4. Now, is this true? Does 6 equal 4? No, it does not. So it's actually, there's no solution. And it never works. Ever. Okay. In this problem, first we need to distribute, so we get 2x plus 3x minus 4 equals, we distribute over here as well, so 4x minus 12, yep, 12 plus x. Okay, so we get, what, 5x minus 4 equals 5x minus 12. Okay, and hang on a second. Oh, I made a mistake. Hopefully you caught my mistake before it was too late. I didn't distribute the 3 to the 4. That would be a big problem. So let's back up. Alright, we distribute the 3 to the negative 4, we get negative 12. And then that carries itself down here. Okay, now you can tell already that they're the same on both sides, right? But just for fun, let's finish the problem out. We subtract our 5x's. They disappear. And you're left with negative 12 equals negative 12. So this always works. No matter what number you plug in to this formula, to this equation, it's going to work out, always. So you can plug in pi and it'll work out. Alright, so an example here, the perimeter of a rectangular carpet is 200 meters. The width is 3 times the length. What are the dimensions of the carpet? Okay, so let's just say, so we have the length, right? Now the width is 3 times that length, right? So this is 3 times longer than this one, so we should do 3L. And then obviously it's rectangular, so it's the same over here, and this is L as well. Okay, now we know the whole perimeter is 200 meters, right? So we just do length plus 3L plus length plus 3L equals 200. Alright, and then we combine our like terms. We have a whole bunch of L's over here, right? And so we combine them, we get what? 6L, 7L, 8L equals 200. And let's see, if we divide by 8, L equals 25 meters. Okay, now we know that the width is 3 times as much as that, right? So 25 times 3 is 75 meters. Alright, last one here. Alright, given that Celsius equals 5/9 times Fahrenheit minus 32, so if you want to convert between the two, maybe Google's down for the day or whatever, you want to find F in terms of C. So basically what that means is that we want to get F by itself. We want to isolate F, so we want to move everything over to the other side. Okay. And so what we're going to do first is we're probably going to divide by 5/9. You can distribute in this case. I would not recommend it. You're going to get some awful fractions. And at this point, go ahead and just divide. Now, dividing by a fraction is the same as multiplying by the reciprocal, right? And so that's the same as doing 9/5. We flip our fraction and then times C. And then we got F minus 32. Okay, so 9/5 C. And we're going to have to add 32 to both sides, right? Plus 32. So it's going to be plus 32. And now we have isolated F. And we got F in terms of C. Okay, so that's all it is just moving everything over to the other side and getting this variable by itself. That's section 4. Here are your practice problems for the section. If you have questions, let me know. I know that we're probably running into some issues with Schoology and the book and just making sure everyone's logged in. So do your best. Please ask questions when you have them.